All right, with 4.7 and the inverse of trigonomic functions, basically what we're doing is we're taking sine, cosine, and tangent, and we're just reflecting the graph over the line of y equal to x. Whenever you find an inverse, basically what you're trying to do is you're trying to find the angle measurement. Okay? You're given certain values and you're trying to find what the actual angle measurement would be for said angle, okay, or for whatever values you're given. Okay, we'll verify and actually find the inverses tomorrow. Today is basically using like where everything fits in terms of like the unit circle or the kind of like on your hand. Okay, everything today is going to be an exact value. I'll show you how to do anything that it asks for you to use a calculator or for you to like round a decimal. But if it asks for an exact value, basically you're dealing with either pi over 6, pi over 4, pi over 3, pi over 2, or 0. Okay, and accordingly to where everything where that value falls. So whenever we deal with sine, okay, and inverse sine is denoted by sine to the -1 power. Now it can also be written as arc sine. It means the same thing, but you may see something that says like arc sine. Okay, it still means the same thing as terms of trying to find the actual angle measurement. Okay, the biggest thing with any sort of inverses is knowing where everything is restricted at. Okay, whenever we deal with sine, you're restricted from -pi/2 to pi/2. Basically, what you are restricted from, if you think about the unit circle, is that you're only looking at the right side of the graph. You don't care anything really about that left side. You're only going from pi/2 to -pi/2. That's going to be the same case for sine and tangent, but it's not going to be the case for cosine. Okay? So sine and tangent, we're just going to look at the right side of our unit circle. Okay? We're going to kind of look from top to bottom, bottom to top, however you want to look at it, and everything in between. Because remember, whenever we deal with sine, what value are we actually looking at? We're looking at our x or our y value. In terms, we're looking at our y value. Okay? So we need to have a positive and a negative value from it. We don't need two positives. We don't need it to mirror each other. Whereas whenever we find cosine, we will find it to mirror because our x values will have a positive and a negative side to it. Okay? So everything we do will still deal with our hand. And basically it's like we're working backwards. Okay? We're still using the hand trick. We're just trying to figure out where is, like, which one do I need to pull back? Do I need to pull back my pinky finger, my ring finger, my pointer finger, my middle finger, or whatever? Okay? And what do I have? Where is that? Is that pi/6? Is it 0? Is it pi/2? Is it pi/4? Pi/3? So on and so forth. Okay? So remember that whenever we deal with sine and when we use the hand trick, it's everything on the bottom side of our hand. Okay, so wherever that bend is of that finger, the bottom side is going to deal with sine. Okay, as far as trying to either have 1, 2, 3, or no fingers below that bend. Okay, or all 4, I guess. So whenever we do this, okay, you can use the table, but what do you notice about the table in terms of, like, 0's the middle? What do you notice about everything? if it's a positive, if sine of theta, whatever I'm dealing with, and I'm trying to find my angle, what do you notice about the numbers on the right as opposed to the numbers on the left? If 0 is right in the middle. Yeah, they're opposites. Everything on the right side's positive. Everything on the left side's negative. Okay? The numbers are the exact same. It's just one's positive, one's negative. So, you can, if you need to, if you want to memorize the table, memorize the table. That's completely up to you. Okay? But the one thing that you always have is essentially your hand. So, in terms of doing this, I would try to stay away from trying to memorize the table. If that's how you think you can do it, then do it that way. That's fine. I'm not telling you not to, but you've already learned, hopefully, the hand trick and everything that goes with it. So if I'm looking at an angle that is square root of 2 over 2, okay, or a value that's the square root of 2 over 2. So which finger do I basically need to black out or pull back to where I have 2 fingers on the bottom side? The middle one, right? Okay, so the middle one's the one that gets blacked out because I'm looking at the 2 down here. What angle, in terms of radians, is that middle finger? Is it 0? Is it pi over 6? Is it pi over 4? Is it pi over 3? Or is it pi over 2? Pi over 4. It's the one in the middle. Okay, so pi over 4. Now, is this positive or negative? Is there a negative sign with this?
Yes.
Not with the negative 1. Is there a negative with the square root of 2 over 2? No. There's a negative with the inverse. That just means the inverse, or arc sine, whatever you want to call it. So if this is positive right here, then that means that this angle is positive. So the exact value of inverse sine of square root of 2 over 2 is just pi over 4. I'm going to do the same thing. Oh, that's not what I wanted to do. Dang it. I'm going to do the same thing with negative square root of 3 over 2. So again, I need 3 values on the bottom side of my hand. So which finger do I need to black out or pull back, whatever you want to call it? Is it going to be my thumb, my pointer finger, the bad finger, the ring finger, or the pinky finger? The pointer finger, right? Okay, because I have to have 3 values. So that means I'm going to get rid of this one, or that one's going to be the one that's not there anymore. So which angle measurement is my pointer finger? Is it 0? Is it pi over 6? Is it pi over 4? Is it pi over 3? Or is it pi over 2? Pi over 3. Now, the big difference between the first one and the second one is that I have a negative right here. So instead of it being a positive, it was a positive up here on the first one, and it was just pi over 4. Where this one's a negative, so instead of it just being pi over 3, what's it going to be? Negative pi over 3. Questions there as far as how you're going to use your hand to, or use the hand trick, basically. Again, if you want to use the table and you want to try to memorize that more power to you. Okay? I'm just trying to show you a little bit easier way because this is something that hopefully you've been doing since we started. Cosine's going to work the same way. You're going to do everything the same, but instead of looking at the bottom side of my hand, what am I going to look at? The top side of my hand. Okay, because cosine always deals with which value? My x value, right? So I'm going to do everything the same way. The biggest difference here with cosine as opposed to sine and tangent, okay, it's still just my x and my y value flipped. Okay, it's still a reflection over the line of y equal to x. Okay, as far as my inverse is concerned. Now, the biggest differences as far as my restrictions are concerned, instead of it going from negative pi over 2 to pi over 2, okay, it goes from 0 to pi. So what that means is, in terms of these values, I'm just looking at the top side of my circle. So if I think about my unit circle here, I'm not worried about this bottom half. I'm only worried about the top half. So pi to 0, and then I can have pi over 2, so on and so forth. Now, anytime that I deal with a value in this half, you can do this a couple different ways. Question? So if you are dealing with anything on that left half, okay, it's really up to you as far as I would still use the hand trick as far as to figure out, is it 1/2? Is it the square root of 2 over 2? Is it the square root of 3 over 2? What you want to do to figure out where you're at is basically take your reference angle and take pi. Okay, so anything over here is you're going to take pi and subtract either pi over 3, pi over 4, pi over 6, and get your other value. Okay, if you know that pi over 4, hey, it's going to match 3 pi over 4. Okay, it's not a straight flip of a negative sign or an opposite sign like it was with sine and tangent. Okay, it's going to reflect over that y-axis and come over onto that other side. So anything that's on that left side of my function is just going to be like 2 pi over 3. How did I get that? Well, I'm just going to take pi minus pi over 3. How did I get 3 pi over 4? Well, I took pi minus pi over 4. How did I get 5 pi over 6? I took pi minus pi over 6. Everything with this is going off of my reference angle and going up either here, there, or there. Okay? And it's coming up from the x-axis. Okay? On that left side. Okay? Remember, we don't make a triangle with the y-axis, we make our triangle off the x-axis. And that's essentially what we're doing. So whenever we have like cosine or inverse cosine of negative 3 pi over 2. So again, if we go with the hand trick and I'm looking at the top side of my hand. So that means I need to have 3 fingers on top and then 1 left on bottom. So which one am I going to fold back or black out if I'm going to need three fingers on top? The thumb, the pointer, the bad one, the ring, or the pinky? No. Which one? Ring finger. Okay. That means I have to have 3 fingers up here on top. So which one is the ring finger? I think I heard pi over 6. Now, it's negative, so it's not just going to be pi over 6. If it was positive, then yeah, it would be just pi over 6. So where is negative square root of 3 over 2? Or what is pi minus pi over 6? Remember, that's just 6 pi over 6 minus pi over 6. 5 pi over 6. And I'm not telling you have to do it that way. I'm just telling you that's probably that's the surefire way of, if you have, once you find this value, take it away from 1 or subtract 1. Take 1 and subtract that value, and that's going to get you what's left. Okay? Again, you can use the table and you can memorize the table. But I would have another way just in case memory fails you at some point. Okay? Because you always get to use your hand on the test. You always have your hand on the test. Okay? Your cheat sheet is your left hand. Okay? That's the one thing you can basically take with you to the test. Okay? You can't take a table already written down. Okay? Unless it's in your head, that's fine. But if you can still, you've been using the hand trick for a while, so I would stick with doing it that way. Last one then is tangent. Tangent's the only one that I would tell you to probably stick with trying to remember 2 values. Really, you have to remember, if you can remember one, then hopefully you can remember the other. Okay? Your restrictions here are just like on sine, to where it's the right half of my circle. And it's going to go from negative pi over 2 to pi over 2. Okay? Whereas in terms of this one, instead of going from like 1 to 0, it's going to go from negative 1 to positive 1. Or those are the big values that we're going to work with. Okay? Or those are the 2 that are going to really be ones that we've seen a lot of. So whenever we do tangent, the one that I would tell you to remember, okay, it's a lot like sine as far as my table is concerned, that 0 is going to be the cutting point, and then it's just going to be the opposite here. Essentially, if you can remember 2 values, okay, I think you can remember every other one with it. 0 is 0. That one should be hopefully fairly easy. The one that I would tell you to remember, hopefully just like 0, that the pi over 4 and the negative pi over 4, that it's negative 1 and positive 1. Hopefully those are, okay, because what happens when we do tangent? If we pull back that middle finger, everything cancels, right? Whereas if we can remember, the big one too, I feel like to remember, is pi over 3. Okay, if you can remember that pi over 3 is a square root of 3, that's your biggest angle that you're dealing with. Remember, tangent, if we go to our hand, okay, pi over 3 is your pointer finger. With tangent, what do we do with our hand? We flip it over, right? So we get the square root of 3 over 1. Okay? The reason why I would remember that one is that's going to be your biggest angle. Hey, we're not going to pi over, or we're looking at pi over 2, but that's your restriction, so we're really never getting there. So if we have the square root of 3, or excuse me, the square root of 3, and we have pi over 3, okay, hopefully you can remember that in terms of your values. What do you notice about the 2 there? You have the square root of 3 in both of them, right? What's the only difference between pi over 3 and pi over 6? As far as the actual value. I have a square root of 3 and I have a square root of 3, but what's different with pi over 6? It's divided by 3. So if it's divided by 3, it's going to be the smallest of all the angles. It's going to be that pi over 6. You have the same value, but one of them is divided by something. One of them is divided by 3, so it's going to be the smaller of the two. So like if I have the exact value of inverse tangent of square root of 3, well, just like we talked about, square root of 3, I'm going to flip it or here, and I'm just going to have pi over 3. I still need to make sure that it's going to be positive or negative. If it would be a negative square root of 3, then it would be a negative pi over 3. Okay, it's just a lot like sine in terms of my value as far as being the opposite.